So like I said, the highest point on this curve over here, because there's closed dots at the end of each point from the start to the finish, it is not continuous along all the real values of x, or it's not contained in all of the x values in the real number system. So the highest point is at 8 and 7, so that's called an absolute max because there's nothing that's going to be higher than a y value of 7. That happens at x is equal to 8 over the interval 1 and 8 because our curve is bounded by x is equal to 1 and x is equal to 8. So now the lowest point from what you guys can see is at 2 and 1, which means that this is an absolute min because there's nothing that's going to be lower than the y value of 1. This happens at x is equal to 2 over the same interval 1 through 8. So your minimum value is equal to 1 and your maximum y value is equal to 7. So an extreme or an absolute max value occurs at a peak where the slope of the tangent is 0. So f prime of x is equal to 0, or at the endpoint of an interval a, b. So if we have restrictions on the interval, the absolute max will most likely be at the end of it, because as you can see in this curve, it comes down, then goes up, comes down again, then goes up, and finishes off at the maximum. That is dependent on how the graph is drawn. An extreme minimum or absolute minimum occurs at a valley where the slope of the tangent is 0, or at an endpoint of the interval a and b. So your minimum value, your absolute minimum, can be at the end of a curve, depending on where the curve starts and ends. So now there's an algorithm for determining the absolute maxes or mins of a function on a closed interval a and b. So if a function f of x has a derivative at each point in the closed interval, we want to calculate f of x at all the points in the interval where x is less than or greater, less than or equal to b and greater than or equal to a, and where the derivative of f of x is equal to 0, and at the endpoint x is equal to a and x is equal to b. So the absolute max of f of x on the closed interval is the largest of these values, and the absolute min is the smallest of these values. So when using this strategy, it is important to consider the function f of x on a finite interval, that is an interval that includes its endpoints, otherwise the functions may not attain a max or min value. So what that basically means is that if I do not have any close points at the beginning and at the end of my graph, I have to assume that that graph is continuous, which means I may not have a absolute max or absolute min, which is why it is important, if you're using this strategy, that it is contained in a specific interval. So for example, the first one was contained between the interval of x is equal to 1 all the way to x is equal to 8. So this example is where you will start to understand the point of a derivative. So use the algorithm for determining the absolute max and min values for each of the following functions. So the first one I have is f of x is equal to x squared minus 4x plus 3, where x is contained between 0 and 3. It cannot go below 0, past 0 or past 3. We want to sketch the graph to verify the max and the min values. So in order to find my x value of the absolute max or min, I have to find f prime of x, which is 2x minus 4. And we know that if I have an absolute max or min, I have to set f prime of x equal to 0. This will tell me at what value of x my max or min is going to be located at. So I get 0 is equal to 2x minus 4. I get 4 is equal to 2x divided by 2 divided by 2. I get x is equal to 2. Now I need to check if that falls within my interval. Does x equal to 2 fall in between 3 and 0? Does 2 fall in between 3 and 0? Yeah, perfect. So now I can gather all my points. So f at 0 is equal to 3. So I can plot my point 0 and 3. F at 2, if I were to plug in my f at 2, that gives me -1, which gives me over here. And if I plug in f at 3, that is going to give me 0. So now if I draw my curve, I get that. Now, going back to advanced functions, I can literally factor out this parent function, which is factored out to x minus 1, x minus 3, where I get x is equal to 1 and x is equal to 3. And as you can see, once I factor that out, I know that my minimum is going to be at x is equal to 2. And because it's an upward opening parabola, that I'm going to have a minimum and not a maximum. So again, because it's bounded by this interval, I have a max at x is equal to 0, which is 3, and a minimum at x is equal to 2. These would be considered absolute maxes and absolute minimums because of my interval given. There will not be a y value higher than 3, and there will not be a y value that is lower than 2. Or that's lower than 1, -1, sorry. All right. The next question is annoying, only because it goes back to our curve sketching days and advanced functions. So if I were to ask you guys to sketch this graph regularly, what would we have to use? What strategies in advanced functions would you have to use to graph this function? Starts with an S. It has to do with divisions. Anybody remember? Yeah, we would have to use synthetic division. So I would have to figure out what value of x makes my function 0. So if I plug in f at 1, this is going to give me 0. Okay? So let's do my lovely synthetic division. So I get 1, 4, -2, -12, +9. Again, plus, 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 plus. I haven't done this in forever, since last year. So I get 1, 1, 5. And I get 5 over here. And then I get 3, 3, -9, -9. And I get 0. So I get x minus 1 is equal to x to the 3 plus 5x squared plus 3x minus 9. Now again, using synthetic division, I need to divide x cubed plus x squared plus 3x minus 9. And again, if I sub in 1 for my polynomial, I get that function equal to 0. So we use 1 divided by 1, 5, 3, -9, plus, plus, plus. Bring the first number down. 1 times 1 is 1. 5 plus 1 is 6. 6 times 1 is 6. 3 plus 6 is 9. And I get 0. So what I'm left with is x minus 1, x minus 1, x squared plus 6x plus 9. Can someone tell me what the fully factored and simplified expression would be for my last step over here? So what would this be fully factored and simplified? See if you guys remember your advanced functions days. Yep. So this simplifies to x minus 1 squared times x plus 3 squared, which means that at my zeros, x minus x is equal to 1 and x is equal to negative 3. There's going to be a bounce on both of them, okay? So now that we have that, we can find our derivative of f of x and figure out where I'm going to have a max and a min. So I'm going to take f prime of x of my function, which gives me 4x cubed plus 12x squared minus 4x minus 12. So as you can see here, I can factor by grouping. So I'm going to take my first two, factor that. I can factor out an x squared. And I'm left with x plus 3. I can factor out a negative 4 from my other two, and I get x plus 3, which means I'm left with 4x squared minus 4 times x plus 3. I can factor out the 2 from my first guy over here, so I'm left with a 4. My apologies, I can factor out a 4. So I get 4 bracket x squared minus 1 times x plus 3, and then I have the difference of squares, so I get x plus 1, x minus 1, x plus 3. So my roots are x is equal to 1, x is equal to negative 1, and x is equal to negative 3. Now my restriction on this graph to evaluate the max and min values is between negative 2 and positive 2, which is not going to count in my graph. Which one am I not going to include? Negative 3. So negative 3 cannot be included because it does not fall in my domain. So I know that at f is equal to 1, there is a minimum. I have to evaluate f at negative 1. I have to evaluate f at negative 2 and f at 2. So I know f at 1 gives me 0 because we calculated it based off using the original function. If I plug in f at negative 1, I get 16. F at negative 2, I get 9. F at 2 gives me 25. And f at 0 gives me 9. So now I can use this to plot my points. It's going to be an ugly looking graph, but it is what it is. At negative 1, it is 16. At negative 2, it is 9. At 1, it's 0. And at 2, it is at 25. Shit, it's all the way up here. Whatever. You guys understand what's happening. Am I missing any other points? No, I am not. So because it only includes from negative 2 to 2, I can only draw this part of my graph. Bounce off, go up, and stop. So I have my max at x is equal to 2, and my minimum at x is equal to 1. Okay, now C, I'll get you guys to do on your own at home when you have time. We'll move on to the last example 2, and then I'll give you guys the rest of the class to finish up your assignment. So we have technicians working for the Ministry of Natural Resources have found that the amount of a pollutant in a certain river can be represented by P of T is equal to 2T plus 1 over 162T plus 1, where T is between 1 and 0, and T is the time in years. So since a cleanup campaign started, if January 1st is day 1, what was the pollution at its lowest level? So let me rearrange P of T so that I'm not working with a rational. P of T is equal to 2T plus 162T plus 1 to the power of negative 1. Okay. And now what I can do is I can just take my derivative. So I get P prime of T is equal to 2 plus, then I have to use my power of a function, plus negative 1 times 162T plus 1 to the negative 2 times the derivative of 162T plus 1, which is 162. So that means I get 2 minus 162 times 162T. Keep writing 16T. Plus 1 to the power of negative 2. Now that means I can move my negative exponent to the bottom, so I get 2 minus 162 over 162T plus 1 squared. So because I want to figure out when it's at my lowest, I have to set my derivative equal to 0. So what I can do first is I can move my negative 162 over 162T plus 1 squared over to my left side to make it positive. Two over 1. And then what I can do is I can cross multiply. I'm going to move it over here. So I get 162 is equal to 2 times 162T plus 1 squared. I can divide both sides by 2, which leaves me with 81 is equal to 162T plus 1 squared. I can take the square root of both sides, which leaves me with plus and minus 9 is equal to 162T plus 1. So I can move my positive 1 over, which means that I get plus and minus 9 minus 1 is equal to 162T. So I get two expressions. I get 9 minus 1 is equal to 162T, or negative 9 minus 1 is equal to 162T. Because we are talking about time, which expression is not going to work out for us? Because we are talking about time, which expression is not going to work out for us? The negative value. So negative 9 minus 1 is going to give me negative 10, and we divide it by positive 162. It's going to give us a negative value, and time cannot be negative. So we're left with 8 is equal to 162T. And if I simplify that, I get T is equal to 4 over 81, which we can use. So now all I have to do is figure out my P of 0, P of 1, and P of 4 over 81. So I plug in P of 0, it gives me 1. P of 1 gives me 2.006. If I plug in P at 4 over 81, I get 0.21. So now I need to convert this guy into days. So I'm going to take 4 over 81 is equal to 365 days. And if I simplify this, I just get 18.02, which means that if January 1st is day 1, I will reach my lowest level of pollution at January 18th. So with that said, I